Lesson 12.4 is on counting outcomes and theoretical probability. EQ is how can you find possible choices and probability. So we'll take a look at a couple of different things. First, we'll have to know what counting principle is, and also theoretical probability, which you may have worked on for one of those stations for probability. The first thing that we're going to do is to work on drawing a tree diagram. So I'm going to give you some examples when we can use tree diagrams and start from there. Let's say you have an option to create your own sandwich. So you have two different types of bread, two different types of meat, and two different types of condiments. And you have to choose only one item per section. So let's say what are going to be the number of choices that you can have. First, you're going to choose the bread. So first step, I'm going to write the first two choices that I have and leave some spaces in between. And then if I choose wheat bread, I can choose either ham or turkey. Same thing for white. If I choose white bread, I can still choose ham or turkey for my meat. If I choose wheat bread and ham, I have two options for my condiments, either mayo or ketchup. And that will be the same choice. If I choose wheat bread, turkey, I still have two options for mayo and ketchup. Now the same rule applies to the white bread option. If you have white bread and ham, you're still going to have mayo and ketchup for your options. White bread and turkey, you still have mayo and ketchup for your options. So after I make and complete the tree diagram, I am going to have total number of 1, 2, 3, 4, 5, 6, 7, 8 different options. So I have total 8 options. They're going to be slightly different, but none of them are going to be the same. Now, I am going to introduce you to the rule that we're going to use for the future questions. When you have X number of ways of making a choice for the first one, and then if you have Y ways of making a choice for the second choice, you are simply going to multiply the options that you have. In this case, the number of first choice times the number of second choice, we actually have to go to the number of third choice because we had 3 different categories. So let's take a look at it. If we only had bread and meat, you would be multiplying 2 times 2 because you had 2 options for bread, 2 options for meat. And if you see after the first turn, you have 1, 2, 3, 4 different options to make your choices. But because we have the third one, we are multiplying 2 more options, mayo and ketchup. So we did 2 times 2 times 2, which created 8 as a final option number. So I'm just going to put it on the bottom. If you have more than 2 choices to make, then continue to multiply the number of options as you go. So if it's 3 choices that you have to make, 4 or 5, and it's going to continue to be multiplied on the original number. So when we have small options, it's easy and it may be more favorable to use the tree diagram. However, if you have larger numbers to draw from, you may not want to use that because it's going to require a lot of work. So let's go ahead and see possible passwords. Now I'm going to start with 4-digit passwords, and I'm just going to limit it to 4 digits because we don't want to complicate our problems just yet. So I have 4 digits that are available, and I have numbers from 0 all the way to 9 that I can use for each digit. That means even though the numbers are from 0 to 9, I have total of 10 options or 10 numbers to choose from. What I'm going to do is I'm going to write down how many options I'll be having for each of the digits. So I'll have 10 possible numbers. And most of the times when you're setting the password, it doesn't matter if you already used one of the numbers from your option set. So I'll be able to use another 10 numbers, another 10 numbers, and another 10 numbers. So whichever one that I choose It doesn't matter, but I have 10 options to choose from for that specific digits. So what I'm going to do is, this is basically my first choice, second, third, and fourth. So all I have to do is to really just multiply all four numbers. When you do that, you're going to have 4 zeros. You're going to have 10,000 different ways of creating a password with 4-digit passwords. So that's quite a bit of numbers, and you really don't want to write 10,000 options using the tree diagram. One thing that you'll have to know for this lesson is this vocab called sample space. Sample space is basically a list of all the possible outcomes that you can have for that choice. So for example, if you go back to the previous slide, you have all these bread options that you can have for your sandwich. Having that list is going to be the sample space. So if you are asked to write the sample space or find the sample space, you'll have to list all the possible outcome combination to indicate that that's the sample space. So for example, let's say you have a sample of rolling a number cube twice, so rolling a dice twice. You have 6 options for a dice, and then you can have another 6th one for the second round. So what you're going to do is, finding the sample space, you have to actually write down every single thing. For example, if I rolled 1 for my first number cube, my options for the second one can be ranging from 1 all the way to 6. And I have to repeat that for 1 through 6 in order to make sure I have all the sample space provided. So if I have all these 6 numbers, you can tell that I'll have total 36 of possible outcomes, which is going to be the counting outcome part, and you have all the sample space. Theoretical probability is basically counting favorable outcomes from the number of possible outcomes that we have. We put the probability as a capital P, and then inside of the parentheses we have the event that indicates what is going to be the event that you're trying to find out. And then you're going to set up the equation with the number of favorable outcomes on the top and the number of possible outcomes on the bottom, and you're going to find out the ratio, or you're going to find out the percentage in the fraction form. Let's say we're going to toss 2 coins at the same time, or one at a time. So when we're tossing 2 coins, you have 2 options for the first time, or the first coin, which is head or tail. And for the second coin, same thing, you only have head or tail. So you're going to have options like this. So I use the tree diagram to show you the sample space. So I have the first one, if I rolled head, I have the second one either head or tail for possibility. And if I had the first one with a head, I have either head or tail for the second coin. So I have total number of possible outcomes as 4. Now let's say the question is asking, what is the probability, and indicated by the capital P, and the condition with 2 heads for this situation. So I'm going to look at all these options and then find out 2 heads, head and head. I can't even look into this one because it's starting with a tail. So I only have 1 option that's possible out of 4 possible scenarios. So my probability of finding 2 heads is going to be 1 over 4. That is going to be my theoretical probability. In theory, out of 4 times, at least once will be both heads. So let's take a look at this hypothetical situation. Let's say you're buying a lottery and you have to guess 6 digits, 6 numbers correctly in order to get the first place. So what is going to be the probability of buying the winning ticket for this case? So first, you're going to have 6 digits. So you're going to have, again, 10 options, 0 to 9, 10 different numbers that are available to plug in for each of the numbers. So you're going to end up with 6 zeros. So you're going to have 1 million different chances for choosing a different number. Now, for a winning ticket, you only have one combination that will ensure you to get the right number. So your chances of finding the ticket, it's going to be 1 in a million, literally. So even though people may want to get lottery tickets and win them, the chances are very slim. So the homework is going to be from the textbook, and if you watch this video until this part, please draw a smiley face next to your name when you're turning in your assignment so that I know you watched this video. Thank you and see you.